Welcome back to day 3 of the FAA's 2020 International Rotorcraft Safety Conference. I am Steve Barbini, manager of the FAA's General Aviation Rotorcraft Unit. Today's presentations focus on pilot topics. But please note, we are offering Wings, AMT, and IA credits for many of these presentations. If you haven't already done so, to receive credit for IA refresher hours, please enter your email address into the Zoom Q&A box, the Q&A box, not the chat box. For Wings and AMT credits, enter your email address associated with your FAAsafety.gov account into the same Q&A box. If you have audio difficulty, you may want to dial in along with logging into Zoom. Attendees using phone dial-in without logging into Zoom will not receive any credits. Now onto the show. Kicking off today's conference is Nick Mayhew with an update on the work of the U.S. Helicopter Safety Team. Nick is the general manager of the L3 Harris Arlington Training Center in Texas and serves as the industry co-chair for the USHST. He also is a veteran of both Gulf Wars and served for 28 years in the Royal Navy as a Sikorsky search and rescue helicopter instructor pilot. Nick, thank you for joining us today, and the floor is yours.
Good morning, good afternoon, good evening to all of you out there, wherever you are in the world. Hopefully we will get there it is. So hopefully you can see my presentation. So I am going to be talking about the United States Helicopter Safety Team and giving you an update on that. Next slide, please. I will be covering the team's background and structure. I'm going to talk about our goals, or our goal. I'm going to talk a little bit about what our method is, our analysis, and some of the results. What the safety rates are looking at like the moment in the various industry sectors, and then what's next for the United States Helicopter Safety Team. So next slide, please. So the industry and government got together and established the United States Helicopter Safety Team in 2013. So we are a joint partnership. We are a regional partner to the the International Helicopter Safety Foundation, which was established back in 2005, actually, as the International Helicopter Safety Foundation, or it's International Helicopter Safety Team. We are set up similar to other industry and government safety teams. So we're siblings, if you like, to the Commercial Aviation Safety Team, the General Aviation Joint Safety Committee, for GA for small airplanes, and the unmanned unmanned safety team as well. So we are a sibling to those organizations. Next slide, please. So the leadership is, I co-chair the team with Wayne Fry from the FAA. So the industry and the government are both covered. We work with a steering committee of 10 voting members. 8 of those are from industry and 2 are from the FAA. And at the moment, we also have 1 non-voting member in an advisory role. We're supported. We have a number of support teams, again, each co-chaired by both industry and the FAA. We have a safety analysis team who work the analysis on the accidents that we examine. We have an outreach team that takes that information and gets it out to you guys with the help of the communications team. And then to make this all work, we have to have a coordination team. So we have a fairly robust team who keep us on track. We also have a couple of special emphasis areas, which are both industry-led. One on infrastructure in the United States, and one on training. So those are teams that are pretty much they're legacy teams that were brought over from our previous organization when we restructured. Next slide, please. So let's talk about our team goal. And before I get into this, I want to make sure that people understand the difference between a goal and the vision. So our vision, the United States Helicopter Safety Team, is for zero fatal accidents. That's our vision. That's where we want to get to. And that's the aim of the long-term aim, the long-term vision. To help us get there, we have a goal. And we've been updating the goal every 5 years. And our current goal is to reduce the 5-year average fatal accident rate down to 0.55 per 1,000 flying hours by 2025. So this is a goal that began in January of this year. And it is as I said, it's a 5-year effort. And hopefully we will get there and bring this number down. The baseline for our measurement is the 2014 and 2018 5-year accident average accident rate, which was 0.62. So if we manage to get down to 0.55, then it'll roughly be about 11% reduction in fatal accidents. Remember, we're talking fatal accidents here. We believe that if we can attack the fatal accidents first, the accidents will follow in the same reduction. So what the rate goal looks like in raw numbers? So in 2014 to 2018, in the US here, we averaged 20 fatal accidents, helicopter accidents every year. So from 2020 to 2024, which takes us to 2025, we must average no more than 17 per year. That's still 17 too many, but that's what we're aiming for, because we're trying to be realistic to get to our vision of zero fatal accidents. This assumes constant annual flight hours, which has been largely true for the last 15 years. Obviously, annual flight hours do go up and down, and I'm sure COVID-19 is affecting us this year with the number of hours that we're flying. But we can't predict that at the moment, and we don't have the numbers. So that's where we are. We are assuming constant annual flight hours to realize that number. If the goal is met, there'll be 15 less accidents in the next 30 less fatal accidents in the next 5 years. And that means saving a life, and that's what we're trying to do. Next slide, please. So here's the fatal accident rate over the last 20 years. And you can see back at the beginning of the century or the decade, we started at 1.43, and there's spikes and drops as we go through those 20 years. Right now, fatal accident rate is sitting at about 0.76. It's pretty steady has been for the last 2 or 3 years. In fact, it has just spiked recently. We'll see that on the next chart. But you can see that it does go up and down, so we have to take into account which is why we decided to go with the average 5 years. Next slide, please. So as I said, the 5-year average fatal accident rate is shown here. The good news is the trend is coming down. But the bad news is that since 2014, it's been going up again. Not hugely, it's up at 0.7, as I said at the moment, but it is trending up. So something that we need to take into account when we go fly. Next slide, please. So here are the key metrics in 2020. And as you can see, the good news is that last month in September, we had zero fatal accidents. Now, don't get complacent. That's the only month this year that's happened. But it proves that the vision can be achieved. Zero fatal accidents can be done. So the 5-year baseline, as I said, 0.62 over the years, the previous years, 14 to 18, and ramping up, as I've said, to the current year, which is at 0.76. So the average goal we need to get down to is this 0.55, and hopefully we'll drive that down. Next slide, please. So how do we get there? What do we do? So our method is to analyze fatal accidents, and we've been doing that over the past few years, and then propose intervention strategies. The way we take those is we numerically score and rank the intervention strategy for overall effectiveness and feasibility of implementation. There's no point in putting an intervention or a safety enhancement out there that we don't think is going to work, and we need to get our best bang for our buck. And we also need to make sure that you guys will accept any strategies that we propose. So we developed the top rank intervention strategies into these helicopter safety enhancements, and you'll see these as we go through, and then implement and measure the progress of each of those HSEs. Next slide, please. So what is an HSE? I see it as the bridge between analysis and implementation. It is a detailed plan to transform the concept into action. It's led by supporting agencies, and we gather a team to do that. It has specific steps in the plan with expected outputs and a schedule to stick to for each of those outputs. Its development approval process is rigorous. Once we identified the accidents that we were looking at, we identified the enhancements that we wanted to make, and then we draft up the approval. We draft up the schedule for the HSE, making sure that there's no creep in scope. The process is checked regularly by the authors, and there are 2 separate peer review teams that will look at these, and then the steering over and above that, the steering committee then must review and discuss and vote to implement any HSE or any changes to the HSE. Next slide, please. So the analysis that we're working on at the moment is from 104 fatal accidents that we looked at over the year 2009 to 2013. And in fact, we've updated those with some more recent numbers as well. But they were developed on detailed analysis of actually 52 of those fatal accidents, because there are 52 of these fatal accidents, so just over half are in the top 3 categories. So the top 3 categories, as you can see on the left-hand side there, loss of control in flight, unintended flight into IMC, and low altitude operations. Next slide, please. So subsequently, the preliminary analysis of these reinforced that these top same occurrence categories accounted for 50% of our fatal accidents, which is what I just said a moment ago. That doesn't mean that we're still not working in or turning our attention to any of the others. We're still monitoring that, but we feel that the best bang for our buck again is to attack these top 3 categories where 50% of the fatal accidents are happening. Next slide, please. So there were 117 intervention strategies proposed out of those 104 accidents. 25 of those were ranked highest and considered candidates for helicopter safety enhancements. So safety enhancements that we thought would make a difference and were implementable. Some were combined for efficiency and effort, which resulted in a final number of HSEs sitting at 16 that were finally approved. And we broke those down into 4 general areas: outreach, policy, technology and equipment, and training. If you want to see the full list, please go to USHST.org, and you'll be able to see the whole list laid out on our newly revamped website. Next slide, please. So here are our outreach HSEs, safety enhancements, 5 in total. Utility patrol and construction recommended practices was something that we've been working on. Day-to-day safety culture and professionalism, which I think is huge in our industry today. It's something we need to get right. Detect, manage risk level changes during flight. Recommended practices for final walk-arounds of aircraft and hazards over the counter medications. Next slide, please. We have one policy, HSE, and a number of people on our team are working with the FAA on the M&N certification standards and revamping the helicopter safety series, the Rotorcraft helicopter series. So you'll see that following the fixed wing standards coming out shortly, which will, I hope, will introduce some changes that will positively affect the industry. Next slide, please. Technology and equipment safety enhancements, 5 of these. I seem to have lost my, oh, there it is, okay. Safety enhancement, safety augmentation systems, SAS systems, autopilot for light helicopters is something we think is important. Simulation modeling for outside of envelope flight conditions. So this is if you have an accident, typically the simulator doesn't model it because it hasn't been, that data has not been gathered. So we're having a discussion about that with some very intelligent people from NASA and lots of other parts of the industry. Helicopter flight data monitoring we're looking at. Complementary use of the UASs in high-risk environments and operations. And you heard from Mark Colburn yesterday on some of that. Enhanced vision systems. Next slide, please. Our training HSEs, we want to improve the transition training to different make and model helicopters to make sure that people are doing that safely. The next one, which is close to my heart because I lead this one, increased simulation for at-risk scenarios to develop better safety decision making, and that's you'll see if you're going to come to Heli Expo. I'm hoping that you'll see us on the USHST stand. We're hoping to be able to show you what we're doing on that HSE with the help of some people from industry who are bringing some simulators to the stand so that you can run through some of these at-risk scenarios that we have issued as a recommended practices document. We need to improve the understanding of basic helicopter aerodynamics. Tim Tucker's leading that from Robinson. Recommended practices for pre-flight assessments and student flights, and recognition of and recovery from spatial disorientation. Next slide, please. Just looking at the US helicopter flight hours, you can see where most of the hours are being flown over the last 10 years. So this is 2009 to 2018. You will also notice that because of the way that the numbers are reported, we have had to merge some of the industries. For example, aerial observation, law enforcement, and ENG in that 18% top right-hand corner is merged from where we gather the information from. But you can see instruction and training is there's a large portion in there, and we'll see how that affects the accident rate on the next slide, I think. Next slide, please. So here are the fatal accidents for those 10 years. And you can see that just over about 60%, so personal private 25%, HAA, utilities patrol, aerial application, and commercial make up nearly 60 to 70% of the fatal accidents. So those are the areas that we are concentrating our outreach on as well to make sure that we can get to these parts of the industry. Next slide, please. And again, this slide shows you the personal private is way up there with the fatal accident rate per 100,000 flying hours, with the different parts of the industry, the utility, patrol, construction, aerial application, and commercial being there at the top. That's the fatal accident rate. Next slide, please. Here is where the fatal accidents are happening in the different FAA operating parts. So 0.81 general operations in Part 91, 1.17 for the external load people. Part 135, 0.21, so still there, but low, and then 0.96 for the 137 operators. Next slide, please. So what's next for us? We have several of the HSEs are expected to finish in 2020. And we are starting to build a proactive predictive safety capability. So we have both Wayne and myself sit on the executive board for ASIAS, and we now have a Rotorcraft issue analysis team. A riot is the term that some people are referring it to, but we are involved in that sharing of information and analysis as part of ASIAS. So we're hoping that that will create this predictive and proactive approach to stuff that we for the industry. We're continuing our outreach through USHST webinars, and we have webinars every 6 months. Sorry, we have all hands every 2 months, and then every 6 months we try and meet face to face. Obviously, COVID has stopped us doing that. But we do have our webinars that are happening, and there's another one November 18th, I think, is the next one. Please put it in your diary. Hopefully, we will be able to get out there and be able to get face to face with you guys again. But that's how we're working that. And then we work with our partners. Obviously, the FAST team, the FAA, one of our major partners, and we're also developing some ongoing videos that will elaborate on various aspects of the HSE. We have one video we're working on for inadvertent IMC called 56 seconds that you're going to see coming out soon, and that will emphasize the fact that you need to avoid IMC rather than get in it and try and get out of it. So you'll see that coming out. We also work with some other partners called Helicopter Safety Alliance, and we get out there and do go local type presentations and seminars. So if you see those, please work with that. And we're also working with HAI on a number of initiatives. So next slide, please. So that brings me to the end of my presentation. I'm open for some questions, but while you're thinking about questions, please just have a look at this helicopter pilot enjoy your retirement checklist. If you can do all of these things, and you abide by them and you believe in them, then I believe you'll be able to retire in your dream place and enjoy your retirement. Any questions?
Well, thank you, Nick. A lot of great information about the USHST and the job y'all are doing and striving to a great vision, zero fatal accidents, and understand it does take, I guess, progressive steps as getting goals in for each time frame. I do have a couple of questions for you that came in during your presentation. First one I have is, the most common accident faced is loss of control in flight. Is it possible to cope with this kind of accident by training? If so, what is your suggestion on the kind of training, or are there other ways to address this?
Yeah, that's I mean, one of our HSEs is actually the one that's close to my heart, which is training in simulators. And there are a number of situations that you can get yourself into where you could end up losing control of the aircraft. And I believe that that if you, as a pilot, had seen that situation before you got into that situation, into that scenario, then you may not have got yourself into that situation in the first place. So if you can, so that's one of the reasons why we put together this decision-making HSE on simulation, so that you can run through scenarios that we've actually put together based on real fatal accidents. So people have actually got themselves into this situation, and you can run through those scenarios in a simulator and learn from your mistakes. If you get yourself into a situation where you can learn, where you learn by getting it wrong in the first place, do it in a simulator where you're not going to get harmed, and then hopefully you're, having seen that situation before, then you'll be well set up when you get airborne and do it. So to answer the question, yes, training is something that can address the loss of control accidents amongst a good safety culture, and making sure that you don't cut corners, and take into account all the other things that you need to do to operate safely.
Thanks, Nick. And let's see, I'll go on to the next question. Which sector of the industry is the hardest to reach with safety initiatives? What's the USHST is finding the most difficult?
Yeah, that's a great question, and it's normally one that comes up. You know, it's at the top of our list, and we keep asking ourselves that. So I think from the numbers I just showed you, you can see that personal private is well up there in the accident rate, and those are the people out there that we find hardest to reach. So the personal private people who are out there operating by themselves, sometimes without any assistance, and sometimes without safety management systems, or at least the semblance of one. The way we're trying to attack that at the moment is, as I said earlier, our go local meetings, and trying to get out there and get people to come to seminars to listen and learn. And we're also working with both HAI and a company in Switzerland, in fact, under EASA, to try and put together a flight risk assessment tool within an iPhone or a Google app, so that you can load that onto your phone, carry it with you, and carry out your own flight risk assessment with links to all sorts of other information and valuable stuff that you may need to operate the aircraft safely. So there's our challenge, but I'm open to other ideas. If anybody has any idea on how to reach these people, how to reach you, if you're a private operator, what do you need from us to help you operate safely? We'd love to hear from you.
Thanks, Nick. And one of the premises for this safety conference that we started many years ago, I think it's 5 years now, was to be able to reach out to the individual operators, the small operators. Offering this free conference to everybody is one way we had an idea, working with the industry and trying to get outreach further to those that weren't easy to reach. And I think doing it virtually this year, we definitely have increased our participation numbers too. So we're reaching a lot of people. I think I have time for one more question for you. Commenter mentioned that there's a lot of great stats and information in your presentation. Is this presentation available on USHST website, or does the website provide the stats, accident numbers?
Yes, so if you go to ushst.org, you'll be able to drill down into the website to find all our presentations that are loaded up there, and all the statistics and all the studies and reports that we have created from the accidents are also on there as well. So Feel free to browse. There is a lot of information on there, a lot of safety bulletins, a lot of recommended practices documents, hints and help to set up safety management systems, and all sorts of valuable stuff that is available on ushst.org. Please go there.
Thanks, Nick. And as you see in the chat box, Scott Terrell just posted the link to USHST. He's posted a couple of times in here, so doing a presentation, but I encourage everybody to go to that website. Plenty of information, stats, and the HSEs and recommendations how to improve flight safety are all listed there. So Nick, thank you for joining us today and presenting information about the USHST and the drive to get down to zero fatal accidents for Rotorcraft. We do appreciate you taking the time to join us today. Thank you.
Keep it in the green out there. Thank you.
Yeah, thanks. Okay. Next up is Jason Quisling with the topic of human factors. Jason's been flying commercially for more than 25 years in both fixed wing and rotorcraft, and for most of that time in the helicopter air ambulance field. He currently serves as Air Methods Vice President of Flight Operations and as a National Transportation Safety Board trained accident investigator. Jason, the floor is yours.
Thank you, Stephen. And thanks, Nick. Great presentation on the USHST. I'm going to share my screen here. So welcome, everybody. I hope you've been enjoying the conference over the last few days. It certainly has been a lot of interesting information. As I said, I'm Vice President of Flight Operations and Aircom at Air Methods Corporation. We're a large air medical operator. We have a fleet of over 400 aircraft and about 1,300 pilots working around the continental US. I have previously flown the line for quite some time. I was a check airman for approximately 10 years, and I've been actively involved in accident investigation, as well as for the last decade or so, I've been an active participant with the USHST and try and promote outreach, especially in the air medical community whenever I can. So today we're going to talk about aviation human factors. And I want to just set a couple of ground rules because, you know, a unique thing about this presentation is I'm talking about mistakes that people made that sometimes were very costly, sometimes might have even cost them their lives. So this is a very serious subject matter, and I hope that we can take away some good ideas and some new things to think about from this. But at the same time, I am going to try and lighten it up a little bit to keep it somewhat entertaining and make sure that we don't leave here depressed. So I think, you know, pilots are our own worst enemies. Helicopter pilots have a can-do attitude, and they're really trying to always get things done. And they approach things from a unique perspective, right? So sometimes being that eternal optimist and trying to get the job done is what gets us in trouble. The causes of this trouble are really not new. They've been around for literally decades. Back around 1940, we had already identified a lot of the hazardous areas and the issues that create problems with flying in general and certainly in the vertical flight industry. So these are all things that we're going to touch on today. But, you know, I think no matter how many times you might be familiar with them, read about them, think that you're an expert around avoiding some of the hazardous conditions, I think the real challenge for us is we're only as good as our next flight. And so there's always something here that we should be thinking about and remembering and watching out for when we go out to fly. So just a couple of slides. I know Nick gave a really great overview of the USHST. I just want to highlight, you know, in their current focus areas, loss of control in flight, unintended flight into instrument conditions, also referred to as double IMC or inadvertent entry into instrument conditions, and low altitude operations are three areas that we see we can make a very large impact on the accidents that are happening today and tomorrow, and hopefully reduce those numbers. And as Nick mentioned, we do have a few sectors that are a little bit higher interest right now just because of some of the accident rates that happen there. And I think the personal private one is probably the one that's the most challenging because we don't have as many touch points or as much control around the folks that are operating in that sector. So I'm not going to throw a lot of statistics at you, but I do want to bring up one that's actually from some of the original work that the USHST did. And I think it's important to look at some of these statistics from a high level overview and see what are the big takeaways. And when you look at this slide, you're seeing red and yellow, and the red are the fatal accidents. And if you notice where the spikes are, the fatal accident spike in the en route sections, maneuvering sections, and as you get to landing, hover, takeoff, kind of the final approach section, those accidents tend to be more survivable. And I think the big takeaway from that is speed kills, right? So it's very important that as we are starting to lose control of a situation, whether it's getting behind the aircraft in terms of our situational awareness and understanding of what's going on, or whether it is a matter of environmental conditions such as visibility decreasing, we need to make sure the first thing we do is slow down the aircraft. It has a multiple effect on the chances of success for a flight. By slowing down an aircraft, one of the greatest things that you're doing immediately is you're giving yourself more time. You're creating time that you can process the information you have, analyze it and make a decision, and hopefully make the correct decision for that situation. You're also reducing the speed of that aircraft. And by doing so, you start to move yourself into a larger envelope where if you do run into something, if we do have a more catastrophic event, there's a better chance that you're going to be able to live through that, especially if you have any kind of additional personal protective equipment or life-saving gear that you're using on that flight. And depending on your helicopter, what kind of protection equipment was designed into the engineering of that aircraft. Now, when we talk about human factors, we're talking a lot of times in a casual conversation about stupid pilot tricks, right? We tend to take a look at this as if the pilots that make these mistakes are bad pilots. And I think we have to be very careful there on jumping to that kind of a filter, because the reality is that the majority of the pilots that get into accidents are competent pilots. They're well-intentioned pilots. Many of them are safety experts in their field. We can't make mistakes all the time in aviation and get away with them. So I think we have to recognize that even a good pilot can have a bad day and things can go wrong, and that can put us in a place where we could have a catastrophic outcome from time to time. As organizations and systems engineers and groups that try and fix these problems and solve it so that we don't have accidents from the outside, we frequently refer to technology to try and fix things. And that can be great. So FADEC is full authority digital engine controls. This is basically computers on your engine. And this is a fantastic technology. It makes it very simple to manipulate turbine engines. You can keep them within certain parameters. You can protect them from having exceedances caused by the pilot. It can really simplify everybody's life and give us a lot more information and make things safer. But at the same time, when you introduce new technologies, you tend to introduce new problems, right? So in this picture, we have a helicopter that's sitting at a air ambulance base. It's an EC-135, and they get a request one night, and the pilot, the crew go out and they do their normal checks. They get in the aircraft. The pilot starts up the aircraft utilizing a checklist. He gets ready to go, confirms with the crew that they're all good. He pulls pitch, gets into a hover and starts to climb away from this pad. And as he's passing through about 50 feet, he starts to get some alarms, and he looks at his panel and things are not looking right. It looks like he's had an engine failure. In reality, we have FADEC controls on this aircraft. So instead of manipulating the twist grips, you're actually utilizing little switches to take the engine from off to idle to fly. And one of the engines is in the fly position and one of the engines is in the idle position. Unfortunately, as all of this is transpiring and the pilot is coming to grips with what's going on and starting to understand, the aircraft is now 50 to 60 feet in the air. It's drifted off to its left there, and it's over a fence. And as the pilot is struggling to maintain rotor RPM and lift, he ends up descending into a parking lot below the helipad and the rotor blades hit a empty semi-trailer, and the aircraft rolls over with substantial damage. Fortunately, everybody was able to walk away from this crash, but it's a typical situation we see where we have a modern day aircraft with systems designed to make it safer and prevent these kinds of issues. And then we have human intervention, and for some reason things go wrong. And, you know, as a chief pilot or a director of operations or a person that owns and operates these aircraft, you can get very frustrated. And it's very easy to say to the pilot, you know, well, you have two simple switches there. Why didn't you just use a checklist? But I think this is where we have to start to understand the role that human factors plays, right? So human factors is not just about the fact that we make mistakes as humans, but it's about understanding why that occurs and recognizing what we can do about that and what we are not going to be able to do about that. And we'll talk about how do we deal with situations where we can't control every outcome. But I'm going to play a video for you right now because I want to give you a sense of what I'm talking about here. And I think this video is a great test for each of you to be able to take a look and see if you have that perfect concentration and you're able to get through any of these situations without making a mistake.
So to demonstrate how often our body is working against us, we're going to watch a video with a little test. You need to count the players in the white as they pass the basketball. How many passes do the players in the white make? It's a very difficult test, so don't feel bad if you don't pass the first time around. So how many passes did you count? If you had 15, you were correct. But did you see the gorilla? No, seriously, there was a gorilla. This video is a great example of what we call attentional narrowing. By priming your brain to focus on the people in the white shirts, I was able to trick it into ignoring other pieces of relevant and even extraordinary information in your visual field.
So I think this is one thing that I don't like about virtual presentations is I can't see the audience and get the interaction, but I would suspect that the majority of you out there probably missed the gorilla unless you have seen this video before and been through this test. And these are the ways that we can very simply miss an item on a checklist. So you can have a very well-intentioned pilot that's actually trying to do everything correctly and by the book, and we can still make a mistake that can end up being critical. And that's why it's important to have additional checks and balances. So the idea of multiple times that you might check a critical item, the idea of doing a hover check and getting the aircraft stabilized at 1 or 2 feet above the ground and validating that everything is working the way it's supposed to. If it's not, you have the ability to actually just set it back down and fix the problem. These are some things that we have to think about. So a little bit of theory around human factors. Dr. James Reason is considered to be the founder of modern day aviation human factors theory. And when we talk about how we make mistakes or unintended actions, we're talking about essentially 2 categories, slips and lapses. So slips are an error of commission. For example, I'm flying a aircraft. Let's just use an airplane as an example because we have multiple levers up front. I'm coming in and I have to put the landing gear down to land. I know that, I see it on the checklist. I reach over to move the landing gear lever to the down position, but I grab the wrong handle and I move the flaps on the wings to the down position and leave the gear up, and we have a gear up landing, right? That's an error of commission. An error of omission or a lapse would be where I have to do something, such as I'm coming into land and I need to put the landing gear down. I see it on the checklist, but then as I'm getting ready to do that task, I get a call from ATC. I answer the call and I move on my checklist to the next item and I fail to actually get the landing gear down. So there's an error of omission. I think helicopter pilots are a group that has been classified probably by insurance agencies as being eternal teenagers. And so I'm going to play a video here that kind of talks a little bit about how we overestimate our abilities and we tend to underestimate the consequences of outcomes of those actions as well as some of the limitations around how we judge things.
This video gives us a great example of how even the smallest little changes in our environment can have severe impacts on our performance, and we don't always recognize that. This is an airshow performer practicing a carefully choreographed routine in preparation for a show. If you were listening closely, you may have heard that this was a relatively windy day. As a result, we can't see what's happening to those invisible rotor vortices, but you can be guaranteed that they are there and they are affecting your performance, sometimes negatively. These are some of the invisible hazards that we manage on a daily basis, and sometimes we don't realize how close to the edge we are. Just like teenagers, helicopter pilots tend to overestimate their abilities and underestimate the consequences of their actions. Watch the tail of this air medical helicopter as it departs this accident scene. Judging the clearance around rotor systems is extremely difficult to do accurately. Pilots frequently overestimate these distances.
So I think you can see that sometimes the senses that we have, sometimes the systems of our body and the way that we process information really get in the way of us understanding accurately what reality actually is. And I think one of the areas that we see this most commonly is around pilots and clearance with the rotor systems, particularly the tail rotor. Many of us think we have a good sense of where that is, but especially since in most aircraft you're going to have a blind spot where you cannot see that, it's extremely difficult to accurately know where the tail rotor is. And then our visual system is just not that wonderful at determining accurate distances. So while we may develop techniques and workarounds that allow us to be pretty accurate most of the time, just like the warning on your mirror, objects are usually closer than they appear. So what is the role of aviation human factors? It's really a system for us to understand why events are occurring, right? We can take a look at the broader picture. As I mentioned earlier, we generally have well-intentioned, oftentimes highly trained and very skilled pilots that get into these accidents. So it's not as simple as just having a bad pilot or a pilot with poor skills. I know that as a pilot, we would all love for that to be the case, because I can look at an accident and say, that will never happen to me because I'm much better trained. I'm smarter than that. I've attended a safety conference, right? Whatever those may be, we want to believe that that's not going to be us. And so we have a way of kind of isolating that pilot as being unique in the fact that they didn't have the right training or skills for the situation. But human factors tells us differently. It allows us to take a look at the full breadth of what went on, not just the root cause of an individual made a mistake, but how did the organization impact that? What kind of social factors might have influenced it? What kind of things could the pilot do? Where did his perception systems fail him? Where did his decision-making fail him? Right? This is what human factors can tell us, and it allows us to then try and control the rate at which we have these mistakes and these accidents occur. So one of the key things for us to avoid any kind of an event is to make sure that we maintain situational awareness. And there are three basic levels of situational awareness. The first piece, level one, is perception. You have to properly bring in or process the information that your body is absorbing around you. All of your senses are collecting that information on a second by second basis. But if we don't properly see all of the information or collect that information, maybe it's from our hearing or our sense of touch and feel, right? It can come from a lot of different places. But if we don't have an accurate perception around this information, we are starting off from a deficit already, because our version of reality is not going to match what's actually happening. When we can get that version of reality in sync with what's really going on, level two is comprehension. We want to be able to take that information that we brought in, and we need to understand how it impacts me in the situation that I'm in. Level three is going to be projection. And this is the ultimate level of situational awareness. This is where we would like to live all the time as a pilot. We're getting the information in accurately, or as accurately as we can. We're comprehending what that information means to us in our aircraft. And then most importantly, we're projecting that information into the future to determine what's it going to mean to me in 15 or 20 minutes? How is that going to impact me? And this lets us get out ahead of that aircraft so that we can be making decisions around how we're going to deal with changing conditions. We can be making decisions about what are the options if something doesn't go right with my intended plan here, right? This is how we stay ahead of the aircraft. And as you start to feel yourself getting more anxious or more confused about a situation, right, we're losing pieces of this situational awareness, and that's causing us to slip further and further behind, which starts to be a very dangerous situation. So these are some common areas, common red flags, if you will, that if you're having a flight and you're starting to experience these types of situations or these types of feelings, then these are warning flags that you're starting to fall behind that aircraft, and it's time to fix that quickly. So as I mentioned before, with visibility, we would naturally try and slow down the aircraft. Whether or not we have a visibility issue, when we have these things happening, we also need to build time for ourselves. So that could involve slowing down the aircraft. It could involve getting to a safe place, either climbing to a safe altitude and a place where you're not going to run into other aircraft and work through the problem, or possibly landing the aircraft and stopping the flight for a minute so that we can get back into a mental mode that matches what's actually happening. James Reason also talks about classic mistakes and violations. And so obviously, this is a doctored photo. United doesn't generally fly their aircraft underneath the Golden Gate Bridge, but it's an extreme example of what a violation might look like. Other extreme violations could be intentional acts such as the German wings accident, where you have an individual that actually intends to hurt somebody as a result of a particular flight. However, I think it's important to understand that we make mistakes every day, which are conscious decisions to do a particular action, but it has results that we never intended. We also have conscious actions to essentially break the rules, or at least bend them, right? These are violations that occur on a daily basis, and like a little white lie, these are minor things. For example, I would assume that almost everybody on this call, at least once, if not multiple times a day, has exceeded the speed limit by 1 or 2 miles an hour, right? Why do we do that? We do that to be more efficient, and we think that the risk associated with it is worth that additional extra minute or two that it gets us to the destination, right? We have flight crews that do this all the time, trying to be more efficient, trying to get the job done. But in the process, these little violations can add up. And if you do the right one at the wrong time, they can result in an accident. We're going to take a look at a video here. I'm going to play the video, and then we'll talk a little bit about it. It's an Apache gunship helicopter camera, and they're on training flight. They're flying at anywhere from 15 to 40 feet above the ground. This is a route that they've flown before, and they're going to end up flying through this forested area. The pilot flying is going to attempt to fly between a couple of trees, and I want you to just listen to their communication, and we'll talk about it.
Shark 24328, Eagle, good afternoon. What's your sign code? Yes, do you have a transponder code? If not, squawk 0201. Foxtrot's current flow to restricted area, the altimeter is 3044, will report ghost.
Think I can make it in between there? Nope. Oh, yeah, little fast. Look how big that is. Oh, oh shit. I've got it. Okay. Get it on. Eagle, mayday. 974, down at Bagel. Get it on the ground.
Apache 974, roger, can you give me the next W?
So I think one thing about the video is it shows how frequently we go from a normal flight where everything is happening the way we want it to a flight that's out of control or possibly has a catastrophic outcome, literally in the matter of seconds sometimes, right? Things can happen very dynamically, very quickly in the aircraft. So this is normally where I would query the audience about what did you hear there, right? I mean, I think there are some statements that if you don't have additional context around them, it would be very easy to say, you have a cowboy pilot here. He's got a macho attitude. He thinks that he can do just about anything, and he's not really concerned about the consequences because he believes his skill will overcome any challenge, right? But if I take that same video and I add additional context, like let me say that the accident pilot had been on that training route, flying that training session a year or so prior, right? He was very familiar with the route. He was very familiar with the aircraft, and he had previously flown between the trees without any issue, right? Well, over the course of time, what happens with trees? They grow, and so your clearance may change. And when it's nighttime and when you're using a vision enhancing device like night vision goggles, you start to lose some of your acuity. You start to lose some of the ability to accurately determine what are the clearances there, right? Now, the pilot sitting in the back of the aircraft is a current instructor and have been flying the route relatively recently, right? So you can see how with that additional context, this interaction starts to make more sense. And you could actually look at this as two professional pilots. In one case, one has an inaccurate picture of reality. In the other case, the other one does, but things happen so quickly that they can't seem to stop that train. No matter whether you're a commercial pilot, a private pilot, no matter where you fly, year in and year out, we manage to take perfectly good aircraft and fly them to the point where they run out of fuel and the engine quits. And unfortunately, many times we end up with an accident following these events, right? There have been multiple in recent history, but I think the one piece that I would ask for you to think about on this is that almost 99%, 0.9, almost 100% of those pilots knew that they had a low fuel condition prior to the accident. Most of them saw the indication in the aircraft. Most of them probably had some thoughts and planning decisions prior to that. And the majority of them, while they were in flight, were looking at the gauge, and the gauge read accurately. So for the majority of pilots that experience this situation, it's not a surprise, but somehow we let ourselves be surprised when the engine actually quits. And we have many options in a helicopter that you don't necessarily have in fixed wing aircraft. As Matt Sicaro once said, you need to just land the damn helicopter when the low fuel light comes on. But planned continuation bias is another scenario where we hurt ourselves, because the further we get into a flight, the more committed we are to making it all the way to completion of our intended goal. And so this is a place where you've got to really be able to swallow your pride and recognize the situation for what it is. Fly the aircraft first, deal with the emergency, then figure out how you're going to deal with your pride. Probably one of the most deadly encounters we can have is with inadvertent IMC, or unintended flight into IMC conditions. Visibility is key to all flying, whether you're IFR or VFR. At some point, you have to be able to see things to maneuver the aircraft safely off the ground and back onto the ground. And if you're on a VFR flight in particular, the more visibility you lose, the harder this is, as well as many of us are not practicing a specific procedure and the specific flying skills you need to be successful if you have a double IMC encounter. This is extremely important. You need to have a plan, you need to train using that plan, and you need to make this part of your regular currency and proficiency habits. We're going to take a look at a video here of an actual double IMC event that took place at my company.
You're watching a recreation of an inadvertent IMC encounter by one of the maintenance pilots in my company while ferrying an aircraft across the country. On the right-hand side, you're seeing still images played back in rapid sequence so they appear like choppy video. Looking through the window of the A-Star, you can see ragged clouds in a scattered layer that are gradually increasing and starting to become broken to overcast. The image on the left is a computer recreation utilizing the flight data from the monitoring system on board this aircraft. The background noise that you are hearing, in addition to the aircraft sounds, is the pilot trying to gather weather information from the next available airport on his route of flight. With the weather not matching the forecast and deteriorating rapidly, the pilot understands that he is quickly running out of options. Being in an unfamiliar area and seeing the visibility dropping quickly, the pilot decides to execute a 180-degree turn to try and go back to the airport that he had departed from. Unfortunately, during his turn reversal, the pilot enters the clouds and loses all visibility. Recognizing that he has an emergency, he attempts to level the aircraft and execute his inadvertent IMC procedure by initiating emergency climb. The pilot is in a survival situation. He is falling behind the aircraft and struggling to maintain control. So far, he has done a good job of maintaining a wings level attitude, but his climb is starting to increase, and as a result, his airspeed is dropping off. This combination is leading to a more unstable aircraft and is going to give him difficulty in maintaining control. The aircraft has climbed several thousand feet and is on its way to the peak height of approximately 7,400 feet sea level. As the climb levels off, the aircraft has also zeroed out its airspeed, making it extremely difficult to maintain control. Fortunately, the pilot is able to keep the aircraft wings level, and as the aircraft starts to descend rapidly, it also gains airspeed, allowing the tail to streamline into the wind and make the aircraft slightly more controllable and certainly more stable. Make no mistake about it, the pilot is clearly fighting for his life at this point as the aircraft is reaching rates of descent exceeding 3,000 feet per minute. The pilot declared a mayday during the final moments of the descent, which was so violent that it actually triggered the ELT on the aircraft. Fortunately, prior to any impact, the pilot breaks out of the clouds and regains visual with the surface. He has enough altitude that he's able to flare the aircraft and level it off. There are extreme exceedances to the rotor system, and that's the beeping that you hear in the background. With a visual reference now, the pilot is able to regain control of the aircraft, and seeing the first clear field in front of him, he very quickly sets the aircraft down, glad to be on the ground again. This situation shows how taxing these events can be, even for an experienced pilot. It is critical that you have a plan to deal with inadvertent IMC, and that you have time to practice that plan and those skills prior to an actual event. Without it, you're going to be relying entirely on luck for success.
So you can see that that was a pretty amazing sequence of flight. And there's no doubt about it that without a good deal of luck, this pilot wouldn't have made it through that event alive. That's not to diminish that his efforts and his individual skill in maintaining some control over that aircraft that did make this survivable in the end. And he never stopped flying the aircraft, which was probably the most important piece. However, these situations are going to occur to people, and as the title says, it's unintended or inadvertent encounters. So you're frequently not expecting it, not prepared for it, and this is why that regular practice is so important. In this particular case, this pilot, understandably, after the event was over, he determined that he didn't want to fly again. This was a mechanic who flew aircraft for us in terms of ferrying aircraft around and performing maintenance flights. He was not one of our air ambulance pilots who have a little bit more experience to begin with, but this pilot had a lot of experience. What happened here is he found himself in a unique situation that he hadn't fully thought through. He was flying an aircraft across multiple states. He was in an area that he hadn't flown through before. There's a lot greater workload when you have these new twists to any flight that you're doing, right? And these can start to build up and make things overwhelming at times, especially if the environment and conditions such as the weather are changing rapidly on you. You don't have the easy knowledge to draw on for what are all of the options available. So this is a case where we applied our SMS, our just culture, Instead of just saying, you know, this pilot is an idiot and unsafe and we don't want him in the company anymore, we did a thorough review of the process, and we looked at what are the ways that the organization might have failed the pilot, what are the pieces that we have control over that we should be working on. We went back and fixed those pieces. We gave the pilot time and support to process the situation. And ultimately, he decided that he did want to try and fly again. And so we built out a plan to reintegrate him into flight operations, walk him through that process, make sure that we could recreate this scenario in a simulator and let him experience all of it and understand what happened, what he should do to perform it better if it were to ever occur again, and give him the confidence that he was ready to get back in the aircraft. And I'm happy to say that this pilot still works for us today, still flies for us, and certainly is a competent and qualified pilot. So seeing all of these multiple things that can happen, that snowball effect, right? One mistake leads to another, which leads to another. Sometimes they're escalating in their severity, and other times it's the culmination of adding up all those mistakes together that creates an accident. This represents that Swiss cheese theory, right? So there are little places where we can slip through the defenses and an accident can result. Now, frequently we try and design a better system. So we all know that wires are problems for helicopters, and they can be fatal problems. In my community, the aeromedical side, we frequently have to deal with wires in low visibility situations. And so we have safety systems on most aircraft designed to help get us out as an emergency device in the event that we do get the aircraft in contact with wires. But even these systems have little gaps where you don't have 100% protection. And that's what happened to this helicopter. I'll show you a real quick video here of the actual accident occurring as they're trying to land at an accident site to pick up a patient. They end up striking high tension wires. The wires manage to slip through that little 1-inch gap between the wire cutters and the main rotor blades. And as a result, we had a fatal accident. In this particular case, as the pilot approached the landing zone, he was briefed by the people on the ground that there are wires running across the road south of the landing zone. And we do train our pilots, and I think most people in the industry try and give them tips and techniques to utilize to be able to recognize these hazards under a lot of conditions, right? So one thing we might look for are poles. And if you look at where the aircraft came to rest, off the nose and off the tail on the left side of the aircraft, there are 2 poles sticking up, and it's quite easy to draw a line between those poles and say, okay, there are wires there. But in reality, the landing zone commander was not talking about these wires between these poles. He was talking about the high tension wires that were south crossing the road as the helicopter approached that landing zone. And unfortunately, we're sometimes a little bit quick to take information, process it, and make an assumption around it instead of getting secondary information or backing it up. So this is a area that we have to be very careful of as pilots. Wires and helicopters do not mix well. And in this case, because those wires got past the safety device, they were actually able to get in contact with the main rotor mast and ultimately severed the flight controls, leading to the accident. So it's important to understand whether it's a severe case like we just talked about, or whether it's day to day. Just because you're not seeing something wrong does not mean that everything is safe and that we're doing a good job. We have to always be thinking about what is it that we don't know. I can't I should say you shouldn't overestimate the benefits of a pre-flight and looking at your aircraft. And I can't tell you how important this is to having a long, healthy flying career. This is the tail rotor section on an EC-145. This sits several feet up in the air, and without a ladder, you can't get up here to look at this gearbox. But on the left-hand side there, we are clearly missing one of the attachment bolts for the tail rotor gearbox. And whether you're an A&P or not, I'm sure you know that this is not a great way to fly a helicopter. This bolt apparently had a vibration issue and sheared while I was on a training flight. We were doing this training flight at night. We landed back at the base a little bit after midnight, And we did a post-flight walk around, which is policy at our company. And as I was walking around and shining the flashlight up there, we noticed that the gearbox had a particular sheen to it that it didn't have when we initially took off. So we pushed the aircraft into the hangar, we climbed up on the ladder and we looked, and sure enough, we saw we were missing a bolt. And when we looked closer, we saw some pools of oil in some of the ribs on the gearbox. And when we wiped that away, we noticed that there was an extremely large crack running across about a third of the gearbox. At that point, we called the mechanic, we grounded the aircraft, and later we would come to find out, as we examined this closer, that all of the oil was gone from the gearbox. We had just completed a 2.5-hour flight, and I don't know when the bolt came out, but I do know that if we had gone back out for another 2.5-hour flight as we were planning, we would have been in dire consequences and potentially been in a situation where skill and luck were not on our side. We're going to shift gears a little bit and take a look at hazardous aerodynamic conditions. I've got a video here that demonstrates two that are very similar, and sometimes we confusingly overlap how we talk about these things.
Aerodynamics for helicopters are extremely complicated and have to be respected. In this case, we have a helicopter operating at a high density altitude and near the performance limits of the aircraft. What might look like a settling with power event is actually a case where the aircraft simply didn't have enough performance to arrest the rate of descent prior to running into the ground.
What the
While the previous event falls more in the power settling category, that should not be confused with vortex ring state, sometimes referred to as settling with power. This condition can happen to a helicopter of any size and performance level. Many pilots are aware of how a tailwind can dramatically decrease your performance and allow the aircraft to enter a vortex ring state condition. But pilots also need to avoid flying in their own rotor vortices, especially during a descent, and should avoid excessive maneuvering, particularly in the pitch axis. In this case, the aircraft has a headwind, but as it descends, it's descending into its own rotor vortice. You can see the telltale coning of the blades, which are a clear indication of getting into a condition such as vortex ring state and a loss of lift that results.
So I think vortex ring state is a condition that we all probably need to take a closer look at. There's been some highlighted information that have come out in recent years that I think adds some twists to the way that we normally think about this, and if you're an instructor, the way you may have taught it. I think that the conventional recovery technique and the Bouchard recovery technique are excellent tools to deal with an encounter with vortex ring state. But I think a big piece that we should be thinking about is not just the recovery, but also a discussion around really avoiding this. And it's not just a rate of descent issue. I think we simplify and don't give enough credit to how we're maneuvering the aircraft, especially larger pitch angles, what that's actually doing to the lift available on your blades, and how it may set up a condition for vortex ring state a little bit more easily. So we need to spend some extra time thinking about the performance of our aircraft, but also recognize how frequently we might fly that aircraft at the edge of the envelope and not actually realize it. So in a lot of these situations we've talked about, I think one of the overriding things that you've seen is we have a normal flight, and in the matter of seconds, we go to an abnormal flight and an emergency situation, right? So dealing with dynamic, stressful, high workload, rapidly changing environments, we need a system that allows us to process information quickly. And if we have anyone else on the aircraft, we'd like to be able to use them as a resource. When we're single pilot, there are still a lot of things that we can do to set ourselves up for success and practice that single pilot resource management, right? Being organized, being knowledgeable about your aircraft, staying in touch with the weather, staying in touch with the maintenance on your aircraft. All of these things can help set us up for success. There are a multitude of ways that we can improve our resource management, and making sure that we're ready every time we get in that aircraft to deal with the unexpected is a key element of being successful in our flying. We're going to take a look at a video here of a F-16 that's on a training flight. It has two pilots in it, and as they're taking off, they're going to hit a bird. And I want you to listen to the conversation because I think this is an incredible example of professional CRM at its finest.
I could do close right stop. Keep clear right. I could do. Oh, shit. Okay, we got T6NL. T6NL. Engine. Okay. Around the horn, restart. Yeah, not done. Okay. Yeah, not done. Just gonna try to get a relay going. Okay. You get her from the front. All right, I'll fly the plane. Okay. Okay, engine stop. Stop. Okay, perfect. Okay, you cool? Second, see your engine. T6NL. I'm ready. Okay. And Viking 2, we're ejected to the north. We have an engine failure. Okay, prepare to bat an aircraft. Ready. Eject, eject, eject. Viking 2, copy your brake out to the north.
So a great example of professional aviators exercising their skills at the highest level, right? In less than a minute, we have a very complex turbine-powered aircraft lose its power plant at a low altitude. The pilots are able to quickly and calmly work through and attempt to restart the engine twice. They work through an ejection checklist. They're both on the same page. They manage to make a call to inform ATC, and they've ejected from the aircraft before ATC even understands what's going on, right? So this is CRM demonstrated at its finest level. Now, we don't all have to be CRM experts to get the benefit of it, and we don't have to spend hours and months practicing these skills to become good at it and make it effective in the way we fly. It would be great if we could devote that kind of time to it, but I'm a realist and I know that the majority of private pilots are not going to be doing that kind of work, let alone commercial pilots. The key is to think about the basics here. A simple question that works every time is, what's our plan? You can ask this before you start a flight. You can ask this during a flight. You can ask this in the middle of an emergency. It can really save the day. I was flying in Alaska one time. I was doing heliski work on the glaciers. It was a beautiful bluebird day, meaning the sun is out, unlimited visibility, gorgeous white mountains. And I had to fly an external load, sling a tank of fuel up onto the glacier so that we would have a remote fueling site. And as I brought that tank into land, I had a beautiful clear day. And as it touched down and broke through the snow, I started to develop a whiteout situation. Now the heliski guide was riding with me because he was going to help with some of the cable disconnections. And as the snow started to build up and I knew that we were going to white out, I did the next thing possible. I slid a little bit to the side and I pressed the button to jettison the cable, and that didn't work. The hook had frozen and it was not releasing the cable. I tried to jettison it with the manual lever. I tried to apply a little bit of pressure with the aircraft to break through the ice, and nothing was working. And we were starting to bobble around inside this white fishbowl with very little visibility. And the heliski guide, who I'm sure was terrified and thought that we were going to die at that moment, looked over at me and calmly said, "How are we doing? Right? What's our plan?" And I had several thoughts of a response that went through my mind very quickly. None of them were polite or pleasant, but in that moment, it allowed me to take a breath. And as I took that breath, I noticed that I could see above the top of the cloud, and there were some beautiful mountaintops sitting up there that were fixed reference points. And I was able to use that to stop the movement of the aircraft, to get a moment to collect my thoughts, calm down and think about how are we going to get out of this. And so then with a little bit more maneuvering, we didn't have a way to land next to the fuel tank, but I did have the ability to spend some time working on that hook by moving the aircraft around in a safe manner and avoiding dynamic rollover. I eventually was able to get the ice to break and the hook to release, and we were able to fly away safely. And I really credited that heliski guide as the reason that we got through that successfully, because he said the key question at the key time that made me focus on making sure that we're taking action in the appropriate priorities. So start a dialogue. If it's with yourself, that's fine. If it's with other people in the aircraft, that's fine. If they're non-aviators, that's okay too. You can still use them as resources. You can tell them something like, the visibility is really bad right now. It's about 5 miles and it seems to be decreasing. If it gets to about half of what it is, we're going to find a field and land, right? Anybody, aviator or not, can figure out when things look half as good as what they had seen before in the past, and now they can help keep you honest. So using personal minimums, having in-route decision points, making sure before you even start a flight that you understand for that flight, what are the criteria I'm going to use to decide when enough is enough and we need to stop this, right? Have that planned out before you take off and stick to what your plan is. Okay, for this video, we're going to take a look at an exceptional flight, but not from a good perspective. So I think this video does a lot to speak for itself. I'm going to play it in entirety. This one's a little bit longer, about 3.5 minutes, and then we'll talk a little bit about what this might mean in several different aspects.
Oh, somebody's flying a RC airplane down there. He's got a little runway map. That's just perfect. I love it. That's perfect. Uh-oh, he just crashed a bitch. He just crashed. Did he really? I swear to God he did. Right in the trees. And it's stuck up there. Let me see the helicopter for a second. I have all 3 controls. No kidding. Yeah, she's in the top of the trees. Oh, I see him. I see the guys. I don't see it yet, but it went right in the tree. Way up in the tree. You know how cool it would be if we could scoop that thing out of the tree for him? You know how big of a friend I would have? Do it. Wow. Darn it. Way up in the top of the tree. Nice eyes. I don't know how you saw that. I see everything. All right, take that carburetor heater. That's a P-51 Mustang too. Carburetor heat's off. Damn, right in the treetop. What do you think? All right, our tail's clear. Yeah, what I'm gonna try to get you to do is grab the wing. Yep. All right, we're clear on the tail, a little bit further up. Try to get you to grab that wing tip. I'm gonna put the nose of the helicopter right down here in the bushes. Check my tail for me. Yeah, very good. Back left a little bit. Got it. Hold on to it. You reckon I got permission to land down here now? Oh, yeah. Hold on to it. Tripping, son. Watch the rotor. Yes, sir. Hold that wing down.
Safety first.
Hold it out for him. Yes, sir. Hold on to it. Oh, really? Hey, you got it. He saw it. He saw it all. I find these fucking things too. I love them. You're so welcome. It was my pleasure. It don't matter. I'm okay with that. My name's Timmy. I own the helicopter business out there. If that ain't the sickest fucking thing you've ever done, huh? That's a story for the ages, right? Is it? All right, brother, you have all 3. Sick. Damn, I reckon. Dude, we got that on camera. Oh, my God. That was his first time. $800 worth of airplane right there. I mean, hell, he's got some money tied up in that thing. Oh, dude, that was ridiculous. You know, I forgot we had that. Dude, we got camera rolling, brother. We're going to see this whole thing. I can't wait to watch it. We'll watch it when we get back to. Oh.
Like I said, I think the video speaks for itself. There's so many things to unpack there, but you know, I would start with anybody that is watching this that's a flight instructor. Think about all of the things that we just taught that student in terms of cultural norms and what's acceptable behavior. Think about the disadvantage that that pilot's at right now in understanding about performing a risk assessment, about thinking about what could go wrong, about making that evaluation. Is the risk worth that reward, right? All of those things now are way at the bottom of the list for this pilot. And that's something we need to think about when we're training other pilots. It's something we need to think about when we're working in two pilot operations. And for single pilots, right, it's something that the people you fly, whether they're crews or passengers, these are the things that they're seeing and assessing around you and determining from their own opinion what works and what doesn't. But I think we all need to strive to be a professional aviator. We need to make sure that we are executing our flights to the best of our abilities, that we're putting in the time to be ready and prepared and make them as safe as possible. So thank you for your time today. I believe we have a few minutes where we could answer any questions that may have come up.
Well, thank you, Jason. A lot of great information there. There is comments that came across about the information you provided not only applies to Rotorcraft, but also to the fixed wing community too. So some items I way at the beginning, the House of Pain from 1939 era, how much those items apply today too.
Absolutely.
So, one item before I get to a couple questions, there was a question about recovery procedures for inadvertent IMC. There's a comment about being trained to perform a 180-degree turn to get out of it once you encounter it. Just want to let everybody know that the FAA's helicopter flying handbook actually states to avoid performing a 180-degree turn if you encounter inadvertent IMC or unintended IMC, because turnaround is not always the safest route, and executing a turn immediately after encountering the intermittent IMC may lead to spatial disorientation. So just want to let everybody understand that aspect. If you're being trained to immediately perform a 180-degree turn, I refer to the helicopter flying handbook from the FAA. Let's see. So Jason, one of the questions that came across is that what were some of the things you found in your just culture that helped the inadvertent IMC event from happening again in your organization?
No, that's a great question, Stephen. So I think from an organizational standpoint, one of the pieces we looked at was essentially change management, right? You have a pilot that works in one part of the country and typically does 95% or more of his flying there. And then we ask him to go pick up an aircraft on the other side of the country and fly it across several states. Now, he certainly has the aviation skills to do this, but we shouldn't have him doing that on his own. So one of the pieces that we did is we designed a more structured system so that when these longer distance ferry flights have to occur outside of a regular region, or a pilot, in this case, a maintenance pilot, doesn't have as much flight time and experience as what we have for our helicopter line pilots doing the air ambulance role, right? We have different gates or criteria that have to be met, and we have a manager that's going to walk through that entire process. So we would have a manager that would sit down with this pilot, and if this happened in the future, and would be working with them to go through how do we ensure that your flight plan is correct? What's the weather going to be like? What are your options if something changes? And we have regular touch points along the way, in addition to making sure that this pilot is in contact with our operational control center, where we also have satellite tracking and flight following taking place. So those are just some of the examples that we used. We also went to the pilot directly for feedback around the situation and what his recollection and his perception of events were, and what were his suggestions for things that could be fixed either individually or with the organization to prevent this from happening in the future.
Great, thanks, Jason. Next question, I guess it pertains to a lot of items are the inadvertent IMC. Next one is, should pilots rely on receiving a special VFR clearance if they encounter reduced visibility during a flight?
So I think the important thing here is that when we start getting into special VFR, We're operating an aircraft in very low visibility conditions, and with the weather, typically these conditions change quickly. So you can go from being able to fly the aircraft to not having enough visibility in just a heartbeat. And so I would make sure that you utilize the special VFR clearance in very strategic and limited fashion, not for a planned longer flight.
Well, thank you, Jason. And that actually brings us to the end of the time frame for your session. Do appreciate you joining us for this conference. Great information. I hope a lot of people are able to take a lot away from it and learn from it. And the lessons learned you provided too really helps. So thank you again for joining us today.
Thanks, Stephen.
Our next presenter is Bruce Webb, who currently serves as Airbus Helicopters Director of Aviation and Community Outreach and was Airbus's chief pilot for 16 years. An FAA certificated and qualified pilot for more than 35 years, his flying experience includes experimental test flights, post-assembly test flights, maintenance test flights, and training flights. His topic today is the issue of unintended consequences. So just remind everybody that Bruce's presentation is planned to last all hour. So we will not likely have time for Q&A at the end, but if you have questions, still feel free to put them in the Q&A box. So Bruce, thank you for joining us today and give you the show.
Oh, thank you, Mr. Barbini. I appreciate being invited to participate in this event. I believe it's worthwhile. And, you know, one of the unintended consequences of this pandemic is that instead of having this in person, we're doing it virtually, which the benefit is now we're broadcast across the world. So there's always a silver lining in any event. And that's what I want to talk about. We want to talk about the unintended consequences of actions. So I find this to be a very clever representation of what we're going to speak about. You cannot kill all the caterpillars and then wonder why you have no butterflies. They kind of go hand in hand. And I believe this presentation will be a nice complement to what you just heard from Jason Quisling. That was a fantastic presentation. This is just another step, perhaps. So what is an unintended consequence? Well, we know, for example, that a consequence is something that happens as a result of an action or a decision. There's a consequence to anything. Some of them are intended. We are choosing for something to occur in a certain way. And so that's an intended consequence. But many times there are unintended consequences. And I believe many people would believe or think to themselves, well, if the consequence is unintended, it's likely bad. It's a bad consequence. And that's not always the case either. Some consequences, which are unintended, may be good or they may be bad. So we'll look at a few. Let's start with one which may seem a bit ethereal or strange, but prohibition. In the United States, in 1919, actually in January of 1919, the Congress in this country ratified the 18th Amendment to our Constitution, which made it illegal to produce, transport, and sell alcohol. Manufacture, transport, and sell alcohol. But it didn't make it, interestingly enough, illegal to consume alcohol. It was never illegal to consume alcohol in this country, only illegal to make it, move it, and sell it. So what was the unintended consequence of this? The intended consequence was that in this country we would have a greater moral fiber, and we would have less crime, and people would not become addicted to alcohol, ergo the whole society benefits. So that was the intent of the Volstead Act, which evolved into the 18th Amendment. But what was the unintended consequence? Well, one of the most dramatic unintended consequences is that organized crime proliferated. The mobs, the nefarious people in the world who were in the past, prior to prohibition, making their money primarily through loan sharking, prostitution, gambling. They made their money in bad ways, but it was a very small market. That's a pretty small market. But you must realize that before January of 1919, it was perfectly legal to consume alcohol in this country, to sell it, to make it, to sell it. So when the gate was shut in 1919, there was a huge demand for alcohol. So organized crime stepped in and began bootlegging liquor. They began manufacturing and selling alcohol. And the result of that was a huge crime syndicate. In fact, during that period, during Prohibition, which lasted 14 years, crime went up about 25% in this country. So that was a deleterious effect, an unintended consequence, which was bad. We can all agree that that was bad. So what changed? Well, in 1933, under some pressure from society, Congress decided that they would enact the 21st Amendment to the Constitution. So they ratified the 21st Amendment in 1933, which it's unique in that that amendment only does one thing. It abolishes the 18th Amendment. And it really what promoted that, what caused that to happen, isn't quite as simple as the public wanted to drink. So Congress responded to that and allowed alcohol consumption. What really happened was we had a horrible depression in that period of time. This country was in a terrible depression. We had the Dust Bowl going on. We'll speak about that in a little bit, but the economy was suffering and the government was making no revenue from tax on alcohol. So truly, the need for revenue probably had as much to do with the 21st Amendment as the desire to help our citizens be happy. So in any case, the prohibition, there was an unintended consequence, and that was crime. That was crime. Kudzu. Anyone from Asia, certainly, or in the southeast portion of the United States will be very familiar with kudzu. It came to this country in the late 19th century, about 1875, I believe that it was. And it was brought here as an ornamental plant for gardens and things of that nature. It's a very attractive plant. It's very hardy. It's easy to grow. It's hard to kill. So it came here as an ornamental plant in the late 19th century. But some of its attributes that I just mentioned lend itself to use as a soil conservation device. So remember in the 1930s in this country, we had quite a problem with erosion because farmers were plowing up all the prairie and we had a lot of loose topsoil. So we had a drought, a lot of wind, and we had a huge problem. So what will help stabilize the soil? So along about 1930, kudzu became a very prominent plant to put into effect to stop erosion. And it was used quite a lot along roadsides when we build roads, and there'd be loose soil when we build new roads. So they would plant kudzu, and of course it would provide great top cover. It would stop erosion. It was fantastic. So it did what we asked it to do. But what's the unintended consequence? Well, it is so virulent, it survives most anything. It'll grow on most anything, and it survives most any environment. So the negative consequence of the plant is that it now is very prolific in the southeast part of the United States. It grows on everything. So what came to this country as a pretty plant evolved into a way to conserve soil, and that was fantastic. But the result, the outgrowth of that was a negative effect, and that was, or is, that it's kind of taking over native species, native plants. So that's another unintended consequence, which is not good. Let's talk about some good ones. Aspirin. Aspirin has been around for over 2,400 years, perhaps much longer, but we certainly have evidence to show that it's been around for at least 2,400 years. And aspirin is a product from the bark of a willow tree. So if you take the bark off of a willow tree and process it, smash it, get the acetylsalicylic acid out of that bark, because that's what aspirin is. It's acetylsalicylic acid. And then if you consume that, if you ingest that material, it is a great pain reliever. So in fact, so much so that Bayer, I'm certain you've heard of Bayer aspirin. Bayer aspirin actually synthesized, they came out with the ability to make aspirin without cutting down willow trees or using the bark of a willow tree, and they patented that. So Bayer aspirin was the first manufacturer of synthesized aspirin in the world, and provided it, for many decades across the world. So now the patents are out and everyone makes aspirin. But the point being is that aspirin's an effective pain reliever. But what's the unintended consequence of consuming aspirin? And it is that it is a very effective anticoagulant. It thins your blood. So I will tell you that from the guidance from my personal physician, I take one small baby aspirin every day. And I've done this probably for 20 years, 15 years certainly. And it is to thin the blood, to reduce the opportunity or propensity for a body to produce clots. And if you've been on an airplane, and I'm certain all of you have been, maybe not recently, but if you've been on an airplane, in fact, the passenger briefing cards for aircraft that are traveling great distances actually have some advice on how to prevent or mitigate deep vein thrombosis, blood pooling in your lower extremities and causing a clot. So to help me prevent that, I take 2 baby aspirin the day before I travel, 2 the day of travel, and 2 after the day I travel to further thin my blood. So it's all done with aspirin. And while it is not perfect, nothing in this world is perfect, it is a very effective anticoagulant, blood thinner. So another good example of a positive unintended consequence. Another one, horsehair. So I'm certain at least the majority of the people in the audience are saying, horsehair? What's that have to do with anything? Well, in 1861 to 1865 in this country, in the United States, we had a civil war. And what happened was that we had the Union, the North Army, and the Confederacy, the Southern Army, and they were in conflict. We were fighting each other, the North and the South. And the Union Army had a very effective naval blockade on the Southern or the Confederacy, a very effective naval blockade. And one of the items which would traditionally be imported to doctors, to the medical field, is suture material like silk thread. So even back then, surgeons would use silk thread to suture wounds. But because the Union Army had such an effective naval blockade on the South, they soon ran out of suture material. So those physicians, those doctors working on wounded men on the battlefield had no way to suture the wounds, which was quite a problem. So in the southern part of the United States at the time, they did have something quite plentiful, and that was cotton. So naturally, they had cotton thread, and that was first used to try to provide to be a substitute for silk thread. But the problem with cotton was that it would deteriorate too rapidly, and then it would allow the wound to open up and they'd become septic and infected. And so cotton was not the answer. But the surgeons had to have something. And I don't know who it was or when it was, but someone got the idea to use horsehair or mule hair. And it could be from the tail or it could be from the mane. But in any case, someone had the idea, hey, you know, a horsehair maybe is that long. It's the proper, approximately the proper diameter. It has approximately a reasonably good tensile strength. It was reasonably strong. But it did have a problem. The problem with horsehair, whether it's the tail or the mane, is that it's not pliable. It's more like number 9 wire or 30,000 safety wire. It's not very pliable. So in order to use the horsehair, what the orderlies, or perhaps it was the doctors, the nurses, I don't know whom, but someone decided we're going to boil it. We're going to take the horsehair and we're going to put it into boiling water to make it malleable, to make it pliable so that we can use it. So that's what they did. They boiled the horsehair, then the surgeons used the horsehair. And what was discovered is that the patients that were being sutured with horsehair had a smaller instance of infection. They didn't really understand why. It was true, but no one really understood why. You have to remember, this was 1861 to 1865, and no one in the world really understood germs or germ theory, at least not many people. So, and if you can just kind of imagine being in that environment in the late 19th century, a surgeon, because they didn't understand germ theory or cleanliness, they would work on a patient here. And if they did have silk thread, let's imagine the surgeon had silk thread. So the surgeon would suture the patient, do whatever he needed to do. And when he or she were finished, they'd put the thread back in their pocket, step over to the next patient, perform the similar surgery, pull the thread out of their pocket and use it. So the silk thread, there was no sterilization of instruments. In fact, it's where the term sawbones comes from in this country, because oftentimes they were using carpentry tools on patients and certainly not cleaning them at all. So from patient to patient to patient. But the horsehair was different because it was brought to them after being in this cauldron of boiling water. It was sterilized. The unintended consequence of boiling the horsehair was it sterilized it, i.e. now less incidence of infection. So then no one understood why. There were 2 men in the world during this time, actually this 1864, 1865, there were 2 men who you will likely know their names, but perhaps you don't know their importance or their background in the history of germ theory. The first is Louis Pasteur. So Louis Pasteur, we've probably all heard of pasteurization, heating a liquid up, milk, for example, to about 100 degrees Fahrenheit, killing all the bacteria in the milk, cooling it back down, and it cleanses the milk, so to speak. And by the way, it also works for wine. I mean, it was used for milk and wine. So pasteurization was something that we didn't have, we didn't understand. In fact, Pasteur patented that process in 1865. So again, we were just on the cusp of understanding germs. At the same time, and Pasteur, by the way, was a French chemist. In England was a British surgeon. There was a British surgeon, and he was studying germ theory as well. He was trying to understand why some patients became more septic, became infected, and others didn't. And he actually studied Louis Pasteur's material. So Lister was the gentleman's name, Joseph Lister. Joseph Lister, the British surgeon, who is often called the father of modern surgery, he developed a technique where he was cleaning all of his instruments with carbonic acid. In fact, he would treat the area around the surgical area with carbonic acid. And while he didn't understand exactly why, what he did understand was it improved the patient's outcome. So the unintended consequence in the Civil War of boiling horsehair was less infection. And, you know, we may have heard of the mouthwash Listerine, that's derived from Joseph Lister. pasteurization. So it was at this time we were learning these things. And the Civil War was just a microcosm of this new understanding. Let's talk about another one that really has relevance right this moment. And that is motor vehicle accidents, MVAs, motor vehicle accidents, car accidents. And you may be saying, well, okay, that's an odd thing to speak about. Think about this. In the 1970s and forward, so I would say certainly in the late 70s and through the late 80s, there was a lot of improvement in automobile safety. Not only installation and requirement to use seat belts, we then got shoulder harnesses, airbags in front, side curtain airbags. Engineers now are putting crumple zones in the vehicles. There's been a lot of technological improvements to automobiles to make them much safer for the occupants. And that's fantastic. I love it. I think, in fact, in the United States, to buy a vehicle, and it may be this year, you cannot buy a vehicle, if not this year, very soon, that does not have a rear camera, a backup camera, because it does reduce accidents. So all of this technology is reducing motor vehicle accidents, and that is fantastic. But what's the unintended consequence of this? And it is that when you need an organ, if you are a person who needs an organ donation, perhaps a kidney, a liver, a heart, lungs, skin, eyes, any of that, there are far fewer organ donors today per capita than they were before the advent of this technology in motor vehicles. So the unintended consequence of making cars safer is that people who need transplants have less opportunity, because at least in this country, healthy people, there were a lot of healthy people killed in automobile accidents, but their organs were still viable. But that's no longer the case. There's much less of that. And interestingly enough, I was searching the internet this morning. I get up quite early, and at 4 a.m. I was reading a news feed from NPR, National Public Radio, and NPR just about a week ago did a piece on how COVID is affecting organ donation. Because in this country, people are driving less. Because we're driving less, there are less accidents. Even with the better, safer vehicles, there's less accidents. So what's the unintended consequence? Less organ donors by 23%. So it's not insignificant. So, these are all great examples. I think they get our minds working, I hope. Let's talk about some aviation specific ones. GPS, global positioning systems. I started flying in 1982. And for those of you out there like me that have been flying many years, we grew up with no GPS. There was no such thing as GPS. In fact, when we began to fly, there was no such thing as LORAN. What we had in a helicopter was either nothing, or we might have had an ADF. And if you were really, really lucky, you had a VOR, but most people did not. Most helicopters in the civil world in this country in the early to late 80s were flying around with no onboard organic nav systems. But today we have GPS, and I propose it is nearly perfect. Today, with WAAS, wide area augmentation systems, and GPS, the fidelity is so tight now, we're only talking about maybe 10 feet vertically and horizontally. I mean, I don't know how we get much better than that. I don't know that much better than that is actually necessary. So I pose it's near perfect. It's very reliable. When we first started flying IFR helicopters, and maybe this was the same in airplanes, I only fly helicopters, but we used to fly with a King KLN 90 or a King KLN 89B GPS. And you had to check RAIM, and there was a lot to it. There was a lot of systems monitoring. Today, really, the systems do it all themselves. I mean, I think that the fidelity, the reliability, the accuracy is incredible today. It's rare to have a GPS fail. But even if we do, most of us have 2 on board the aircraft, if not more, and that's not counting the ones you're carrying personally. They're very accurate. We've discussed that, but the accuracy is so great. If I'm flying IFR, I'll offset my flight path by about 0.2. I'll go like a 0.2 offset to the right when I'm going down like a Victor Airway or a commonly flown route, because I know if I'm flying down that route, we have vertical separation certainly for an oncoming traffic, but I'd like a little horizontal separation too. And I know that if you're oncoming from the opposite direction, we may have 1,000 feet of separation vertically, but we likely have none horizontally because you're flying with that same near perfect box that I'm flying with. So I just offset myself off the center of that airway by a couple tenths. That way, should there be a faux pas, no one hits each other. You know, back in the day when we built Victor Airways, when those were conceived and designed and installed, remember they're 4 nautical miles in width on each side of the center line. So you have 8 nautical miles. Now, at the beginning, when we first started flying aircraft, that was necessary. And perhaps even today with old autopilots, that was necessary. They seem to drift a bit. Not today. Today, the technology is super, super accurate. They're inexpensive. You can buy a good GPS today for $15,000. Very inexpensive. They're intuitive. I believe that most people here are flying with a GPS. Most people in the world are using GPS in their aircraft. You're using them in your cars. You're using them every day on your person with your iPhones or your smartphones. So they're intuitive. I don't believe many of you have ever read the manual, the flight manual supplement, or the pilot guide for the GPS installed in your aircraft cover to cover. Maybe you have, most have not. Why? They're intuitive. We don't need to read it. We can understand without reading it. The human machine interface is great on these devices. The displays, they display topography, of course, airspace, many layers. You can display about anything you want on a GPS today. That's fantastic. But what's the detriment? What's the detriment to all this? I would say we're no longer worried about becoming lost. And you say, well, what's the detriment in that? Well, I believe that it is. We're more likely to fly during times when perhaps we shouldn't. We'll come back to that. I don't think we're very concerned about penetrating controlled airspace. Before GPS, or if we disabled the GPS in your aircraft now, and you were going to fly in an unfamiliar area, let's say I sent you to LA, I believe you would go by the Class B airspace or the Class C airspace or any of it. You would avoid it by a mile, maybe 2, but you certainly wouldn't avoid it by 1/10 of a mile. But today with GPS, people, well, they just range down and go right around that airspace. That's, again, probably not the safest thing to do. So back to not becoming worried about being lost. I believe that people today are subconsciously encouraged or lured into flying in a degraded visual environment more so than we were 30, 40 years ago. And the reason is we're really not worried about becoming lost. In the United States, I can legally fly a helicopter commercially under Part 91 if I remain clear of clouds and have 1/2 a mile visibility during the day and 1 at night. That's very, very low. Now remember, these are the minimums. The FAA is not advocating that you do this. But unfortunately, because it is allowed, there are people who will do this. And unfortunately, it often leads to their demise. If you're flying Part 135, so you're a charter operator in this country, not flying helicopter or air ambulance, but just a charter operator, you can get operation specifications to allow you to fly in 300.5 during the day or 301 at night. Very, very, very low. Now, again, the FAA is not encouraging this. No one would encourage this. But because it is allowed, some people will do it. Now, back when I learned to fly in the early 80s, I didn't fly around in 300-foot ceilings and a half a mile of visibility during the day, or 400 foot of ceiling during the day and a half a mile of visibility. Let's imagine I had a flight from Chicago to Milwaukee. I grew up flying in Chicago. If I had a flight from Chicago to Milwaukee, I didn't take it back in the day when I didn't have any navigation systems. And to be very honest, it wasn't because I was super safe and, you know, I knew it wasn't the right thing to do. I'd like to say that that was the case, but I didn't have the experience to know what I know today. The reason I didn't do it then was I would get lost. To fly cross country and from Milwaukee to Chicago is only maybe a 45-minute helicopter flight, but there's not a whole lot of good visual indicators along that flight. I guess if I could just follow an interstate, but the reality is that's not available. So I didn't go because I couldn't. But today, people just follow the little pink line. They hit direct enter and go. I believe that happens far, far too often. So that's certainly an unintended consequence in my opinion. And the displays draw your attention inside the cockpit. More and more today, we have cockpits with very compelling displays, VFR and IFR aircraft. And so it draws people's attention inside. And if you're flying a VFR helicopter, or even if you're flying an IFR helicopter in visual meteorological conditions, you must use your eyes for separation. Even IFR, if you're VMC, you're still responsible to maintain visual contact. But people have a propensity now to look inside too much. iPads or personal electronic devices. We fly with iPads. I fly with an iPad. I fly with an iPad and iPhone. They're fantastic. There's a tremendous amount of information available, right? You can get the METAR, the TAF, winds aloft, fuel prices, you know, you name it, you can get it on your iPad now. But what's an unintended consequence? It takes mental power. It takes a little bit of mental drain to do this. So you're more heads down, and to apply the information takes more mental acuity. And what I mean is, for example, let's imagine you're flying north. You're going to fly 360 on the heading, and the winds aloft at 3,000 are 080 at 20. At 6,000, they're, I don't know, 260 at 25, and at 9,000, they're 180 at 1. What's the best altitude to fly at? I don't think you can figure it out quickly and intuitively. If you have an FMS, a flight management system, you may. Well, actually, it'll do it for you. But my point is, all of this information still requires the pilot to think. And while you're thinking about things you don't have to think about, you're taking attention away from perhaps flying the vehicle. And at the end of the day, maybe it gives us a false sense of security. I believe having all that information available on your iPad, we have more information available in the cockpit today than we had available in our offices 30 years ago. And because of that, I fear that people will often take a flight and essentially say that they will figure it out on the go. They'll figure it out as they go. That's not so safe. And potentially an attractive nuisance in the cockpit. We've talked about that. And lastly, a physical impediment. You still have an object that's loose typically. I mean, most of us don't have it strapped to our thigh. We have a knee board, we have an iPad. You can't have everything strapped to your body. So it is potentially an impediment, and the cords and the backup batteries if you don't have USB ports. So they can be physical impediments as well. We have seen accidents where iPhones or iPads have caused a problem. So be aware. Let's talk about a couple of cases, some examples. So when the EC-145 was delivered in this country, the 145, the 135, those two aircraft really were the inception of fantastic digital autopilots, at least in the Airbus family. The Dauphins, the Dolphins, we were flying them. The 155 had them, but for popular use, the 145 and the 135 really escorted that digital technology into this country. And, you know, these 3 and 4 axis, so 3-axis pitch, roll, yaw, 4-axis pitch, roll, yaw, power, they're very accurate and very reliable. Most aircraft are flying with at least 1 autopilot, 2 autopilots, each with 2 cars. So there's a tremendous amount of redundancy, but they're reliable in and of themselves. So what's the unintended consequence? We want accuracy. We love that. We love the ability to really fly hands off with the confidence that the ship is being flown better than you can fly. I think for many old people, when we learn to fly, and we learn to fly with old analog autopilots, I believe a very competent pilot could outfly the analog autopilot. So if you practice and you trained, I believe 30 years ago, a pilot could fly better than the analog autopilot. That's not the case today. I don't believe there's a human being in the world who can outperform these digital autopilots. So what's an unintended consequence? We can become complacent because every time we ask it to do something, it does it perfectly. It does it seamlessly, reliably, and accurately. So if I come into a room and every day I walk in the room, I flip the switch on, the lights come on. None of us walk into a room, look at the switch, identify the switch, command it to the on position, and then confirm lights are illuminated. We don't do that. But of course, our lives don't depend upon it. In an aircraft, we should all identify the switch we're going to command to a different position. Then we command it to a different position, and then we need to confirm that it's occurred in the way that we desire. But it's pretty easy now to just press the button knowing full well it's going to work correctly. But there's still a human involved, and humans make error. We had an accident, it happened in 2009. It was a VFR flight. The helicopter was an IFR helicopter with a 3-axis autopilot. It had TAWS on board. It also had Max Viz, which is a standalone device. It's a very small, it's like having a goggles, but it's displayed on a display. So anyway, it had all this equipment and it descended right into the surface. It descended right into the surface of the ocean. The pilot likely either engaged altitude acquire and then pressed the button, disengaged it. Because our products, our aircraft won't descend below a certain value or below a certain airspeed when coupled to a pitch mode. But if you couple to a pitch mode by engaging altitude acquire, that's a vertical speed mode, but you press the button again, you uncouple from it. So that may have been what happened, or the pilot actually failed to provide the aircraft with sufficient power to level off. The aircraft will attempt to level off at about 60, 65 feet. But in this case, because it's a 3-axis autopilot, it has no ability to command power. So it'll come down to 60, 65 feet, it'll level off, and it'll maintain 60 knots. But if there's insufficient power to maintain 60 knots, it'll descend, continue to the water in this case. So it's likely a failure to confirm the aircraft was perfect right up until it impacted the surface. So likely a little complacency. Modern turbine engines. What can be bad about modern turbine engines? Well, our reliability today and the power output has increased dramatically. With single crystal blades now, we can pump more heat through that engine without fear of failure. With FADEX, we have the ability to really tightly control those engines. So the engines are vastly superior in the power output and the reliability than even 20 years ago. They're much superior. So that's great. What could be the unintended consequence of this? Well, you can take off with an engine at idle. If you were watching Jason's presentation immediately prior to this one, he gave an example. It's happened many times, not simply in Airbus products, but in many manufacturers, probably all manufacturers' products. And it's because people are not following checklists and doing what we would consider to be some basic skills, using their basic knowledge to avoid these events. I'm not going to go into all that right now, but the reality is a modern twin-engine helicopter today likely has the power to depart on one engine. And it seems like a new problem. And I've had people tell me, well, Bruce, we didn't do that when we were young and flying twins. Well, there's a reason we didn't do it. While I have no recollection of this, I'm not saying it didn't happen. If you flew an old twin-engine helicopter, something built in the 70s, those aircraft had insufficient power to do it. If you were flying an old twin-engine helicopter and you had one engine at fly and one engine at idle and you tried to fly, it wouldn't go. The rotor would just decay. Not with new ones. We now have that power. But again, it doesn't come with a cost, or it doesn't come with a price, or without a price. It does not come without a price. So this happens far too frequently. It's getting better. Perhaps with strict adherence to checklists, it's getting better. We may fly faster than is safe because we have more performance. So the engines will pump out more power. You can fly faster. You can also fly lower with more confidence because you're less concerned about an engine failure. And I'm not saying any given person on this call is doing this or susceptible to this, but I am saying that I believe that it does occur, and maybe even subliminally back in the back of our minds, this can occur. So be careful. There were a couple of accidents here. So I'm going to talk about the turbine engines, the twin engines. So we had an accident here in the Dallas area. It happened back in 2002. It happened very near here in Fort Worth. And kind of a brief synopsis, what happened was the pilot had landed the helicopter on top of a helipad structure. So it was really two helipads with an interstitial space, which was smooth and level as well. So on top of the building, you can imagine a 20-meter pad with another 20-meter pad separated by a 20-meter interstitial space. So there was a lot of room up there. This organization had just adopted twin-engine helicopters on wheels. So apparently, the pilot was talking to a crew member about how to do a running takeoff. They were just discussing the benefits of it, how it could be executed. And they did this waiting for another crew member to arrive. They had landed on the hospital, I believe, to pick up a tow bar. So for you, those of you who have flown EMS or helicopter air ambulance, you know that when you land on a hospital roof especially, you bring your engines to idle for noise abatement and for odor. They don't like the smell. Oftentimes the air conditioning units suck from there. So the pilot brought both engines to idle. When the crew member got back on board and they secured the aircraft, the pilot said, well, I'll just show you how to do a running takeoff. I'll just demonstrate one to you. So he released the brake, applied some collective, little forward cyclic, started rolling down the pad, rolled, kept pulling power, and went right off the edge of the helipad. I believe it was 21 feet down to the parking structure. Two engines at idle. Both engines were at idle. Fortunately, no one was critically injured. There were some pretty serious injuries, but it was a testament to the aircraft that there weren't fatalities. So the aircraft performed perfectly. The aircraft was perfect. It was human error that caused this. There was another one. Another event happened about a year later. So this one happened in 2002. The next one happened in 2003. This happened in Dallas, which is about an equal distance east of where I'm standing right now from the previous accident. In this case, the pilot had one engine at fly and one engine at idle, much like the case that Jason was describing. It was a different event, but much the same. So the pilot picked it up to a hover on the helipad and took off on one engine. And, again, there's a lot going on in your mind. And so the pilot made essentially a 270-degree turn and came back and hit the top of the helipad. Say, but that may be, he hit the top of the pad. No one was injured. And so that's great. But again, failure to confirm, failure to perhaps an overabundance of faith in the system. We still must confirm. And because we have this power doesn't mean that, it can't pose a problem, a consequence. An S-76, this accident happened down in Louisiana in the Gulf. I say lack of regulation. That may be unfair in that, the regulations were there. What happened here was the operator here is a fantastic operator. They did nothing wrong. It was just a collaboration. We know the James Reasons model, the slices of Swiss cheese. Well, they all lined up here. So what had happened was the operator had removed the cast acrylic windscreens. They had removed those for weight savings and cost. And they had installed, they removed the laminated glass. They removed the glass, heavy, expensive glass, and put in cast acrylic. So what happened? There's nothing wrong with that. It was perfectly legal. It was perfectly reasonable. And they had done it for many years. Unfortunately, the aircraft was traveling through space on the way out to an oil rig. 2 pilots on board, several passengers in the back, and they hit a bird. It was a 2.2 kilo bird. I believe it's 2.2 kilos. Hit the center of the windscreen, between the 2 windscreens. It didn't penetrate the aircraft, but the percussion was such that it brought both fuel flow control levers back to idle. And this isn't the time or the place to discuss OEI VNE versus AEO VNE, but the reality is, if that happens, it's virtually unrecoverable. And in this case, the aircraft crashed and all souls were lost. So it was a horrible accident, but it was the consequence of putting in a perfectly legal, perfectly reasonable windscreen, but no one really understood the full consequence of that. The regulations have since changed. So, we shouldn't suffer another similar event. So we've talked about a lot of different things, both socially, prohibition, the Civil War, but now, and then we talked about aircraft events, some unintended consequences pertaining to aircraft. But what I really want to talk about, the consequence I really want to focus upon, is something that's perhaps not thought of enough. And I believe that as a society, and I'm not speaking only about aviation, but as a society in general, certainly aviation, I believe we have a propensity to reward poor decisions and likely ignore good decisions. So what happens when we do that? The unintended consequence, if I reward poor decisions, what's the unintended consequence? Really, I'm promoting those unsafe events. I'm going to give you a very good example in a moment, so follow with me. And I also believe, I hear a lot, people will say, well, my organization or, people, I felt undue pressure have to do the job, right? I felt outside pressure to go. Pressure was applied to me. I mean, we've all heard that. And I'm not saying that does not happen. I'm not. But I am saying in my life, I believe the pressure to go has come from within far more often than external pressure. It's been me fighting my desire to do the mission, to do the flight, to go. So I think often external pressures, I'm not saying they don't exist, but I think they are overridden, if we're honest, by our own internal pressure to go. So let me give you an example. Does anyone recognize this? This is a very famous photograph. It was published across the world. I'll come back to the photo in a moment. Does anyone recognize that call sign? Palm 90. Palm 90. So I'll go back to the picture. That right now is a Bell 206 L1. Good helicopter being flown by the U.S. Park Police. The date is January 13th, 1982. It's about 4:30 in the afternoon Eastern time. And we're going to come to it a little bit later, but I will tell you right now, the conditions are 200-foot ceiling, 0 visibility, 24 degrees Fahrenheit, and moderate snow. 200 foot, 0 viz, 24 degrees, moderate snow. We'll come back to that. By the way, when you look here, you can see it's an L model. He does have an SX-16 on the nose. There's his the person in the back with a buoy on a like a nylon rope. And there's a person over here in the water, and they're trying to drag people from the accident to the shore. And there's about, it's difficult to see even me standing here, there's about a dozen people on the shoreline here. So we'll come back to that. Let's go to the call sign, Palm 90. Palm 90 was the call sign of the 737 that was operating that day out of DCA, Reagan National Airport. It was a 737. And the aircraft, I'm going to have to go back just a little bit. The aircraft departed DCA, it broke ground at about 3:59, or let's just say 4 o'clock. 4 o'clock that afternoon is when it actually broke the surface of the runway in an attempt to fly south. What had happened that day, though, was in Washington, D.C., there was a blizzard. From that morning until approximately this time, there were 6 inches of snow accumulated. And so businesses were shutting down early and people were going home, trying to go home. So the roads were all very congested at this time. And in fact, just about 4:30 in the afternoon, 4:30 in the afternoon, actually, a Washington, D.C. metro train had an accident which killed somebody, which further congested things. So it was just a nightmare day in DC. So what happened was this 737 is at the gate. They load the passengers. When they load the passengers, they're unable to push the ship back from the gate because the tug has insufficient traction. So the pilot, the flight crew, they decide to use the thrust reversers, the buckets, to add power to push off the gate. That's what they do. It's in contravention to the flight manual. It's not allowed, but they did it. They also failed in the checklist to turn on the EPR heaters, the engine pressure ratio heaters. They didn't turn those on. So that really was probably the fulcrum by which all of this hinged upon. They didn't turn on the EPR heater. So when they set their power to take off, for a helicopter pilot, think about torque. You know, they were going to take off with 80% torque. But because they didn't have good torque reading, in this case it's an EPR, they really tried to take off with 60% torque. Well, the plane won't fly. So again, they didn't use the proper procedure to get off the gate. They went to the de-ice pad. They got de-iced. There were some problems with that as well, but I don't have time to go into all of those. They left the de-ice pad, and on their way to depart, you can hear the captain ask the first officer, and the first officer was the pilot flying. You could hear him say, keep her up to the ship ahead. Keep her up close to the aircraft ahead. It was an MD-80. And the captain was encouraging the first officer to keep his 737 close to the ship ahead to take advantage of the heat off his exhaust to keep the aircraft de-iced. That's also in contravention to the flight manual, but they did it. Well, what's heat do to glycol, by the way? If you do heat glycol up, I'm pretty sure it evaporates. So it's got there's an unintended consequence to that. So it doesn't matter. They get to the departure point, they add power, they take off. Well, they attempt to take off. When they add power, they immediately know that something is wrong. But instead of stopping and try to figure it out, they just careen down the runway. It took them almost 3,000 more feet of runway to get it airborne. And honestly, at that point, they just pulled aft on the yoke to get it airborne. The ship traveled about 3/4 of a mile. So from the time it lifted off of DCA until it hit the 14th Street Bridge, it traveled about 3/4 of a mile. It only went up to about 350 feet AGL and was in the air for 30 seconds before it hit. And unfortunately, there were 74 fatalities. 5 people on the bridge were actually killed because remember I said there was a blizzard, so people were surface trafficking. The bridge is really a bridge complex. I believe there are 4. There's 2 uppers and 2 lowers. And they hit that complex called the 14th Street Bridge. Again, it killed 5 people on the bridge, 4 people on board the aircraft, 4 passengers lived, and 1 crew member lived of the aircraft. In that, those survivors, 4 of them were directly attributed to this park police long ranger dragging people to the shore. And so that was great. That is fantastic. You know, that's great. He saved 4 people, and that is great. The problem is, was that a good decision? And I know a lot of people will say, well, it was a good decision. He saved 4 people. He was flying in 200-foot ceilings, no visibility, moderate snow, 24 degrees. And by the way, an airliner just crashed. I don't think anyone's op specs would allow for that. And I'm not, you know, that pilot and crew, that pilot medic did what they thought was right. I think that was a very poor decision. So they were only 2 to 3 miles from the bridge, so they flew to the bridge. The pilot received the Department of Interior Valor Award, HAI Crew of the Year, Coast Guard Silver Lifesaving Medal, and the Carnegie Hero Medal. That's what the pilot got. For flying in those conditions, he won all those awards. Remember I said we often reward bad behavior? I don't think any operator out there would say, yes, I want my aircraft to be flown in 200 24 degrees Fahrenheit and moderate snow. I don't think so. Let's talk about the Maryland State Police. They have helicopters there. One ship sits at Andrews Air Force Base. It's only 10 miles distant. 10 miles. They didn't go. Do you think they wanted to go? How bad do you think that crew wanted to go? They're 10 miles from this accident. They're flying an aircraft very similar to what was being flown there. They're flying a very similar aircraft, and they're trained to do rescue. They're equipped and trained to do rescue. They have sliding doors, Billy Pugh nets, rescue divers, medic. I mean, they are trained to do this. But the weather was too bad, and they didn't go. There was another Maryland State Police ship at Martin State Airport. Now, that ship was 40 miles distant. They couldn't go. I mean, no one is going to fly in 40 miles. But they made the hard decision. It's much harder for these Maryland State Police pilots to not go than it was for the pilot who did go to go. It takes a lot of internal fortitude. It takes a lot of respect for the rules and understanding that you cannot endanger other people. And I'm not saying to castigate the guy who did this. I'm not saying to throw him in jail. What I am saying is you cannot reward this behavior. We've hovered in situations like this. We've all hovered over water. When you're hovering over water, what happens to this water? You regenerate it and it goes through the rotor system. Does that ever ice up the aircraft? Sure. Why didn't he ice up? Well, there's 10,000 gallons of jet fuel in the water. Do you think he knew that and calculated that into his decision? Of course not. He made a visceral, emotional response to go. They're not equipped to do rescues. They don't have sliding doors. They've got a hinged door and a swimming pool with a nylon rope, a swimming pool thing. I'm being a little facetious, but the reality is that's not a safe event. We look at all these people down here. If he'd iced up his tail rotor and crashed and killed all those people, we'd all be saying, who made such a bad decision? But because it turned out okay, because his bad decision turned out okay, in fact, for 4 people, it turned out fantastic. We reward that. And again, I'm not saying to castigate the pilot. I am saying these pilots who didn't go, they should all have been spoken to, and someone should have said, thank you. Thank you for not going. Thank you for doing the responsible thing. but they weren't. I know because the pilot flying this aircraft that day worked at Airbus for many years. No one said anything to them about, we know that was a tough decision. Thank you for doing the right thing. So I'm going to finish with this. This is our industry. It's ours. Let's behave like it's ours. When you see someone do something that maybe doesn't appear safe, doesn't appear reasonable, I'm not saying go out and shout them down. I'm not. Maybe you go out and just ask, just query them and say, hey, you know what are you doing? Or, help people make good decisions. But more importantly, when you see someone make a tough decision, or when you see someone do the right thing, which is often harder than the wrong thing, acknowledge that. It doesn't matter if you're their superior, their peer, or their subordinate. If you walk up to that person and say, I want to tell you, thank you. I know that was a hard decision and I appreciate it. We can change this industry. We've got to stop rewarding bad behavior and instead acknowledge good behavior. So that's all I have. I thank you very much for your attention. I don't have time for questions. My email address is here. If anyone would like to ask a question, please send me an email. I will respond. The FAA has my information as well. So if you don't get it, just ask the FAA. So I thank you very much for your time. And now back to Mr. Rarbini.
Thank you, Bruce. A lot of good information and a lot of good concepts to really think about, unintended consequences, which we may have not thought about before. I also want to say, I believe this is also your fourth conference you presented at all the conferences with us. And I have to say thank you for each of those conferences. You have a lot of information, different one each time. Good information you present. Well, let me know that we'll go on to our lunch break. We have approximately 1 hour for a meal break. Our next presentation will begin at the bottom of the next hour in about 59 minutes. So we'll see everybody back then. Thank you.